Hello everyone, this is Ponsaneza. I will be covering Chapter 4 on hypothesis testing. Learning outcome. By the end of this topic, you should be able to define what it means by one-tailed and two-tailed tests, define type 1 error and type 2 error, and also identify the types of hypothesis testing. Basically, the subtopics involved are one-tailed and two-tailed test, definition of basic terms of statistical hypothesis, followed by probability of type 1 and type 2 errors, and lastly, the steps involved in hypothesis testing. Now, let us look at the three different types of tail tests. We have the left tail test, right tail test, and the two-tail test. A left tail test has the rejection region in the left tail of the distribution of the curve. A right tail test has the rejection region in the right tail of the distribution curve, whereas for the two-tailed test, since it is called as two-tailed, therefore it has the rejection region in both tails of the distribution curve. Now we look at two basic terms involved in hypothesis testing. They are null hypothesis and alternative hypothesis. The null hypothesis, denoted by capital H subscript 0, is usually the hypothesis that is assumed to be true to begin with. It states that a given claim or statement about a population parameter is true. For the alternative hypothesis, denoted as capital H sub 1, it is a claim about a population parameter that will be true if the null hypothesis is false. Next, we will look at the types of tail and the signs of the test and relate it with the null hypothesis and alternative hypothesis. For the left tail test, the sign can either be equal or greater or equals to for the null hypothesis, and we use the less than sign for the alternative hypothesis. For the two-tailed, the sign of the null hypothesis would be equal sign, whereas for the alternative hypothesis, it would be non-equal sign. For the right tail test, the null hypothesis, the sign it takes would be equal or less than or equals to, and the alternative hypothesis, the sign is greater than. Another important feature in hypothesis testing is the types of errors. We can either have a type 1 error or a type 2 error. Condition of type 1 error occurs when true H0 is rejected, whereas type 2 error occurs when false H0 is not rejected. Let's look at the table. It can be divided into two, where we have the actual situation and the decision that we're going to make. If the actual situation, H0 is true, and somehow the decision is do not reject H0, then this is the correct decision. If the actual situation is H0 is true, and the decision is to reject H0, then this is a mistake. This mistake, we call it as the type 1 error. Another scenario would be if H0 is false for the actual situation, and we reject H0 as our decision. Therefore, this is not a mistake. But somehow, if H0 is false and we do not reject H0, then this would be a mistake, and this mistake we call it as the type 2 error. There are two approaches of hypothesis tests. We can either make use of the p-value or we can use the critical value. What is p-value? P-value is a probability value for the observed value of the sample statistic. We can obtain this p-value by using the SPSS output. What we do here is we compare the p-value with the significance level alpha and we make a decision out of it. The decision making would be to reject H0 if your p-value is less than or equals to alpha, or we decide not to reject H0 if p-value is greater than alpha. If we were to use the critical value approach, hence we need to find the critical value or values from a table and find the value of the test statistic for the observed value of the sample. We compare the test statistic either from the Minitab output or calculate the values depending on which test we are using, whether it's Z-test or T-test, with the critical value of values and make a decision out of it. Decision making is a crucial stage in hypothesis testing. We have to determine the type of distribution, the type of test that we want to use, the decision that we're going to make, and also the test statistic that we want to use. Now we're going to look at the steps to perform hypothesis tests. Basically, there are 7 steps. Step 1. State the null and alternative hypothesis. We have to decide whether we want to use a two-tailed test, a right-tailed test, or a left-tailed test. Step 2. Assume that H0 is true, we have to state the distribution for the hypothesis test. Step 3. Determine the rejection region, or also known as the critical region, according to the given significance level alpha. The alpha can be based on the p-value or the critical value. Step 4. State the p-value or test statistic from the Minitab output. Otherwise, calculate the test statistic using the formula given. If you were to use a Z-test, then the formula is test statistic minus mean divided by standard error. And if we were to use the T-test, then the calculation value would be test statistic minus mean divided by standard error. Step 5 is where we make the comparison. We either compare the p-value with the significance level alpha, or we compare the test statistic either from the Minitab output or the calculated value with the critical value. Step 6, this is where we're going to make our decision. And lastly, step 7, we draw the conclusion. As a conclusion, this is the whole overview of what is involved in hypothesis testing.